Usually, when we think about how the law works, there's this underlying expectation of, like, mechanical precision.
Right, very cause and effect.
Exactly. You throw a rock, it breaks a window, and the judge just points and says, A caused B, case closed.
Right, a very Newtonian way of looking at things.
Yeah, but what happens when someone is facing, like, serious prison time? Because a judge attempts to apply that exact same rock-throwing logic to a single retweet on a digital platform.
It completely breaks down.
It really does. And so, welcome to today's deep dive. We're looking at a massive stack of really unique documents for you today. Specifically, we've got these advanced AI analyses from models like ChatGPT, Gemini, Copilot, DeepSeek.
Yeah, and they're all evaluating this fascinating legal defense document that's known as the blood letter from prison.
Which is just an intense title right off the bat.
Oh, absolutely. And the document itself is genuinely remarkable. I mean, it centers on a defendant named Dr. Chen Jingyuan, and he was accused of causing severe public order disruption, which is a charge often colloquially known as picking quarrels and provoking trouble.
Yeah.
And the entire basis for this macro-level systemic charge was his action of retweeting one single post on social media.
One retweet. And our mission today is to explore exactly how Dr. Chen responded to that charge. Because he didn't just argue about, standard free speech or anything.
Well, not at all.
He used hardcore theoretical physics, network science, and statistical mechanics to systematically dismantle the legal claim that his one little retweet caused a macro-level societal disruption.
He essentially brings, like, quantum-level complex systems science into a courtroom that is built entirely on pre-modern linear logic.
That's wild. But real quick, before we jump into the physics of it all, I want to explicitly note for you, the listener, that this deep dive is going to impartially report on the scientific and legal arguments presented in these AI sources.
Right, we're just looking at the documents.
Exactly. We are not taking political sides here, and, we aren't endorsing any specific viewpoints. We are serving purely as your guides to the fascinating scientific ideas contained within this text.
Yeah, the focus here is strictly on the intellectual clash, really. The clash between a traditional legal framework and modern mathematical reality.
Okay, let's unpack this. Because to even begin understanding this battle between legal logic and complex systems science, we have to establish what kind of environment we are actually operating in.
Right, the baseline reality. Yeah.
The prosecution claimed Dr. Chen disrupted the order of the network. What does a social network actually look like? Like, is it this pristine, orderly thing just waiting to be disrupted?
Oh, far from it. I mean, complex system science tells us that social networks are characterized by what's called the small world effect.
Okay.
They are inherently chaotic, highly sensitive, and they fundamentally do not possess the kind of pristine order that the law imagines.
So the law is picturing like a perfectly calm pond.
Exactly. But to really understand why this disorder is just inevitable, we have to look at the foundational architecture of the internet. Specifically, a concept in computer science called the CAP theorem.
Wait, so you're saying the disorder isn't just a glitch or like bad user behavior? How can a computer system be built to intentionally be out of sync?
Well, it comes down to unavoidable physical trade-offs. The CIP in CAP theorem stands for consistency, availability, and partition tolerance.
Okay, CAP.
Right. It was formulated by Eric Brewer, and it states that in any distributed network system, so think of platforms with servers scattered all over the globe, you can only ever mathematically guarantee two of those three properties at the same time.
Only two? Wow, let me see if I can visualize this. Because a massive social network spans continents and cables get cut or, local servers go down, it has to have that partition tolerance, right?
Yes, exactly.
It absolutely must keep functioning, even if parts of it are temporarily disconnected.
That is precisely the reality of the hardware. Now, add the human element to that. Users demand that the app loads instantly, like the exact millisecond they open it on their phone.
Oh, for sure. We have zero patience.
Right. So to provide that seamless experience, network engineers have to prioritize availability. So if you architect a system to prioritize availability and partition tolerance, an AP system, you structurally cannot guarantee perfect consistency.
Meaning that, not everyone is seeing the exact same data at the exact same time?
Yep. The speed of light alone prevents it. Data propagates unevenly. If you and I are on opposite sides of the world, and we refresh our feeds, our follower counts or retweet numbers might look completely different for several minutes.
Wow.
Therefore, a certain level of data disorder or, inconsistency is just the default physical reality of the internet.
It's like blaming a single passenger for the fact that a major metropolitan subway station is noisy.
Oh, that's a great way to put it.
Right. Like, the noise isn't a disruption caused by one guy reading a newspaper. The noise is a structural feature of the concrete tunnels in the moving trains.
Exactly. If we connect this to the bigger picture, the judicial system in this case is committing what philosophers call a category mistake.
A category mistake.
Yeah. They are observing the built-in default background noise of a complex distributed system, and they are legally defining it as a punishable anomaly triggered by a single user.
They're literally prosecuting the weather.
Pretty much.
But, okay, let me play devil's advocate for a second here. Even in a noisy, chaotic system, someone can still yell loud enough to cause a panic, right? Like, how much impact can one single person actually have?
Well, to answer that, Dr. Chen's defense shifts from the computer science of the servers to the mathematical structure of the human connections themselves.
Okay, how so?
He relies on the Barabasi-Albert model, which describes what we call scale-free networks.
What does a scale-free network look like in practice? Because I'm assuming it's not a neat grid where everyone has exactly 50 friends.
Not at all. It follows a severe power law distribution. It's essentially the 80-20 rule, but taken to an absolute extreme.
Oh, gotcha.
You have a tiny handful of massive hubs. These are your pop stars, major media outlets, influencers with like millions of followers.
Right.
And then you have millions upon millions of what are called peripheral nodes.
And where does Dr. Chen fit into that landscape?
Well, his account metrics put him squarely in the deepest part of the periphery. He had fewer than 100 followers.
Oh, wow. Less than 100.
Yeah. And the AI sources analyzing the data note that most of those were what we call zombie accounts.
Zombie accounts, like bots.
Bots, or just users who haven't logged in for years.
So he's practically a ghost town on the outer edges of the map.
Precisely.
But wait, even if he has only 100 followers, what if one of those followers is a hub? Couldn't his tiny spark theoretically light a massive forest fire if the right person happens to be looking?
It is a very intuitive question, and honestly, it's exactly the kind of speculative leak the legal system relies on. But network science doesn't operate on hypotheticals.
Right, it's about the math.
Exactly. It operates on statistical probability and structural robustness. So Dr. Chen counters this argument with Reuven Cohen's critical threshold formula.
Okay, what does Cohen's formula actually measure?
It measures how much damage a scale-free network can take before it just breaks apart entirely. Think of a spider web versus, say, an airline route map.
Okay.
Cohen mathematically proved that scale-free networks are absurdly robust to the random deletion of nodes.
Really?
Yeah, because the vast majority of nodes are peripheral, you could randomly delete almost all of them, and the macrostructure of the network wouldn't change at all. The giant hubs keep everything glued together.
Ah, I see. Because deleting a tiny regional airport doesn't stop global air travel between London and New York.
That is the exact mechanism. Statistically, peripheral nodes connect to other peripheral nodes. Their structural influence on the whole system approaches absolute zero.
So he's basically a drop in the ocean.
Exactly. For the prosecution to assume his tiny node acted as a load-bearing pillar for a macro disruption, it fundamentally misunderstands the architecture of the space he was occupying.
Okay, so structurally, he has zero leverage, but he still pushed the retweet button. And structure is static, but a retweet is dynamic.
Right.
How does the network algorithm actually decide if his specific tweet lives or dies once he sends it?
Well, this is where Dr. Chen introduces the Galton-Watson branching process.
The Galton-Watson branching process.
Yes, this is the mathematics of dynamic propagation. It models how information actually travels from node to node.
You know, this sounds a lot like the math epidemiologists use to track how a virus spreads through a population.
That's because the underlying mathematics are virtually identical. The critical metric here is R0, which is the average branching number.
Right, we heard a lot about R0 during the pandemic.
Exactly. Simply put, for every one person who retweets a post, how many new subsequent retweets do they generate? If your R0 is 2, your one retweet becomes 2, those 2 become 4, then 8.
And it just explodes.
Right. That is a super critical cascade. That is virality.
So how did the AI models analyzing this case calculate the R0 for Dr. Chen's specific account? Like, what does his reality look like?
They looked at his specific parameters. Remember those zombie accounts we talked about?
Yeah, the inactive followers.
Well, when Dr. Chen hits retweet, the platform's algorithm tests that content by showing it to a fraction of his followers. But because his followers are inactive, nobody clicks, nobody likes, nobody retweets.
Makes sense.
The algorithm sees zero engagement and immediately stops showing the post to anyone else. It aggressively throttles the reach.
Wow. It kills the cascade in its crib.
Because of that algorithmic throttling and his severe lack of active network connections, the models estimate his R0 at approximately 0.05.
Wait, 0.05, so literally a fraction of a fraction.
Yes. This places his network activity in the state of deep subcriticality. Mathematically, when R0 is that far below 1, the extinction probability of the information cascade is essentially 100%.
It's guaranteed to die out.
Yeah. You can even calculate the expected total size of his cascade using a simple formula. 1 divided by 1 minus R0.
Good, let me do that math real quick. 1 divided by 1 minus 0.05, so that's 1 divided by 0.95. That comes out to about 1.05.
1.05. That is his mathematical reality. When he retweets something, on average, it generates 0 additional retweets. The buck stops entirely with him.
Here's where it gets really interesting, though. Let's look at the legal threshold required to charge someone with this specific crime.
Well, this is the best part.
According to the documents, the judicial interpretation for a severe disruption often requires a minimum threshold of 500 retweets or 5,000 views.
And we just established his expected cascade size is 1.05.
His actual algorithmic capability is nearly 500 times smaller than the absolute legal minimum required to even begin having this conversation.
Exactly. Which demonstrates why this scientific defense is so completely devastating.
It really is.
The legal system is essentially demanding that Dr. Chen prove a negative, right? To prove that his retweet didn't cause this massive macro disruption. But the branching process math steps in and proves that for a peripheral node with his specific algorithmic parameters, the prosecution's claim is an impossible event.
An impossible event.
The laws of probability dictate it simply cannot physically happen.
Okay, but this raises a massive question for me. If the math definitively proves that a guy like Dr. Chen couldn't possibly make a post go viral, how do massive internet avalanches happen at all?
Yeah.
Because we see digital wildfires sweep across social media every single day.
We do. And Dr. Chen doesn't deny that viral disruptions occur. He's not saying they don't happen.
Right.
To explain them, he points to Perfact theory of self-organized criticality, often referred to as SOC.
SOC. How does that theory explain the viral avalanches?
The classic illustration of SOC is the sand pile model. Imagine dropping sand onto a flat table, grain by individual grain.
Okay, picturing it.
For a long time, the pile just grows into a small, stable cone. But eventually, the pile reaches a critical state. It becomes so incredibly steep that it cannot support any more weight. At that exact tipping point, dropping just one more tiny grain of sand causes a massive avalanche that sweeps across the entire pile.
Okay, so I can see the prosecution looking at that and saying, Dr. Chen dropped that final grain of sand. He caused the avalanche.
But that ignores the fundamental mechanism of the theory. To get a macro avalanche, the entire system must already be in a supercritical state.
I see.
The R0 of the whole network must be at or above 1. The structural integrity of the pile must be completely compromised before that final grain even arrives.
It's like, let's use a different analogy, like a game of Jenga.
Okay, yeah.
Imagine a Jenga tower that has been played for, like, an hour. Players have pulled out dozens of structural blocks from the bottom. The tower is swaying in the breeze. It's incredibly unstable.
Right, a total mess.
Then Dr. Chen walks up, places one tiny wooden block on the very top, and the whole thing collapses. The prosecution is looking at the collapse and blaming the guy who placed the tiny block on top, completely ignoring the people who hollowed out the foundation.
That is a perfect analogy. What's fascinating here is that complex system science proves the collapse is a property of the hollowed-out tower, not the final block.
Wow.
If an avalanche actually happened on this social network, the root cause was the systemic instability of the society or the platform, the missing Jenga blocks. It was not the single grain of sand dropped by a peripheral node. I mean, a grain of sand dropped on a flat table does absolutely nothing.
That shifts the blame entirely from the individual to the environment. But if the system was already a hollowed-out Jenga tower, how does Dr. Chen definitively prove in a legal sense that his specific block didn't provide the energy that knocked it over?
To sever that final legal causal chain, Dr. Chen brings in his most complex argument yet. He applies statistical mechanics, specifically the fluctuation-dissipation theorem, or FDT.
Oh, wow. Formulated by giants like Einstein and Nyquist. This is heavy physics.
It really is.
Break down the mechanism for us. What do fluctuation and dissipation actually mean here?
Okay, so FDT is a pillar of non-equilibrium statistical physics. Put simply, a fluctuation is the tiny, random, everyday background noise of a system.
Like the subway noise from earlier.
Exactly. A user retweeting a post is a microfluctuation. Now, dissipation is how the system absorbs or responds to that tiny push.
Okay.
The theorem states that a system's macro response to a tiny external push is determined entirely by the system's own internal susceptibility, which is represented in the math by the Greek letter chi.
How does that map onto social media data, though? And this specific criminal charge?
Well, the severe public order disruption the prosecution alleges, that is a massive macro response. In physics, we call that a phase transition.
Like liquid water suddenly boiling and turning into steam.
Exactly that kind of state change. Now, FDT dictates that you cannot get a massive phase transition from a tiny microfluctuation unless the system's susceptibility, its internal stored energy, was already infinitely high.
Oh, man. Think about what that means for you listening right now. If you tap a glass of water with your finger, and the water suddenly boils violently, do you arrest your finger for causing a thermal explosion?
Right.
Or do you investigate why the water was already sitting at 99.9 degrees Celsius, just waiting for the slightest vibration?
You investigate the water. You cannot use a microjoule input to explain a megajoule output without violating the fundamental law of the conservation of energy.
It's just physically impossible.
Exactly. For Dr. Chen's tiny retweet to cause a massive societal disruption, the social tension, the algorithmic promotion of outrage, the systemic susceptibility had to already contain all of that explosive energy.
So the prosecution is literally looking at the water boiling and arresting the finger that tapped the glass.
Yes. They are committing a fundamental physics error. They are observing a fluctuation, the everyday background noise of a peripheral node, and confusing it with a phase transition, a macro-level social disruption.
It's wild.
They are taking a micro-perturbation and illegally elevating it as the sole cause of a macro-state change.
So we've taken quite a journey here today. We've seen how a traditional legal system tried to use a very linear, Newtonian, rock-breaking-a-window logic to blame one single man for a massive societal shift.
And it just didn't work.
No. And in response, we saw how the defendant used the CAP theorem, scale-free network robustness, branching mathematics, and the fluctuation-dissipation theorem to prove that the accusation wasn't just unfair, it was physically, algorithmically, and mathematically impossible.
He successfully highlighted that the legal language used in his charge lacks any corresponding reality in the physical world of information dynamics.
So what does this all mean? For me, this deep dive serves as a perfect historical record of a clash between two eras. We are watching modern institutions try to regulate quantum-level digital networks using pre-modern sledgehammers and straight edges.
I agree completely. And, it leaves us with an incredibly profound implication drawn directly from the physics we just discussed.
Yeah.
If network science mathematically proves that peripheral nodes, everyday citizens with tiny followings, cannot cause systemic avalanches, it inadvertently proves that hubs can.
Whoa, wait.
Yeah. If a society's legal, political, and institutional powers are the true hubs of the network, the entities with massive reach, algorithmic power, and systemic influence, what happens when they inject disruptions into the system through arbitrary actions or structural pressures?
They are the ones pulling the blocks out of the Jenga tower. They are the ones pushing the sand pile into a critical state.
Exactly. The science leaves us asking, in a complex, distributed society, who is actually generating the systemic risk and who is the true trigger of this social avalanche?
That is a phenomenal question to leave you with today. As always, keep questioning the systems around you and look closely at the underlying physics of who holds the real power to shape the network. Thanks for joining us on this deep dive. We'll see you next time.